All right, welcome to Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. That's the title of my new book. There it is, that's what it looks like. It's available on Amazon. You can buy it there right now. And what I'm doing is going through the book and just introducing the chapters one by one and what's in them, and answering any questions anybody has who's already bought the book. So right now we're still on the first chapter where I'm introducing to you the difference between base 10 and base 12. And this is an important difference to understand because it's really the first question that everybody asks when we start talking about base 12 is, well, what is the difference? So the difference has to do with the size of the decimal places, not grouping your whole numbers into 10s or 12s, but in the dividing of the 1. So for an example of this, we start with the 1 by 1 square. So here there's no base, we just have a 1 by 1 square. You can see now behind me we have some graph paper where we just have all squares, but there's no division or a line that's accentuating the distance of 1. There, so we have 12 little squares along the side. So this is a base 12 Cartesian plane, or a 1 by 1 square that we would see on the base 12 Cartesian plane. This is a 1 by 1 square on the base 10 Cartesian plane. So you see we're dividing up that length of 1 either in 10s or 12s, or tenths or 12ths. So when we put these two squares next to each other, we can see, I'll say obviously that all those lines don't line up the same. The very center does line up the same because 0.5, which is half in base 10, is equal to 0.6, which is half in base 12. So I got this other example here, this stick that I used to know. You can see the middle, those two lines are the same. But when we start comparing other lengths, let's use the example of 0.7 in base 12 or 0.5 in base 12. So 0.7 plus 0.5 in base 12 equals 1. So those are lengths that are relevant to our diagram for 360 degrees, and that's where we go in the book. We ultimately have access to a geometric pattern. I show you how to divide the circle into 360 degrees. That's something that we can't do in base 10. So we need to understand, how can that be? How can there be something that we can't do in base 10 that we can do in base 12? And it's because we're working with smaller size decimal places. And so on page 22 of the book, I go into that and I'm comparing base 10 and base 12 Cartesian planes. We look at the length of 0.7 in base 12 and we say, well, how would we get there if we were in base 10? Can we access that specific point on the Cartesian plane? So in order to do that, we need to stay in base 10 and try to get to that point. So we have to work in 12s. We're talking about 0.7 in base 12, so that's basically 7/12. So we do that calculation, and 7 divided by 12 in base 10 is 0.583333. So when we see it here, you can sort of see one side's base 10, one side's base 12. When we go the length of 0.7 in base 12, if we look on the other side, we're traveling, it's the length of 0.5, then there's still some distance to go. So we have to divide that square into tenths, then we can travel along it 0.8. We still don't get to the right point. We have to divide that last square into tenths again, then we go 0.3, then we have to keep doing that process of dividing our squares into smaller and smaller chunks of 10 because we're in base 10, and then we get this repeating decimal 0.3333. So again, in base 10, all those decimals are 3/10, 5/10, it's all in tenths and hundreds and thousands. So something interesting we can do here is come from the top down, go the length of 0.5 and do the same thing, 5/12 in base 10. So we're dividing 5 by 12 in base 10, we get 0.41666. So again, we're coming at that same point from the other side of the line. We have a length of 1, we're traveling in tenths, we go 0.4, we go farther, we're going to go past the point, so we have to stop. We divide the next square into tenths, we go 0.1, we can't go farther, we have to stop, we divide that square into tenths, then we go 666. So if you put that 0.41666 above the 58333 and you add those numbers together, you basically get 0.9999. So that it just shows that there's always a little gap between these two lengths where neither of them ever actually reaches the final exact precise length of 0.7 or 0.5 in base 12. So that's all we're showing here. That example is just to show that there are points that exist on the base 12 Cartesian plane that aren't accessible from the base 10 point of view. So that's all we're trying to do, so that you understand that we are accessing different lattice points that don't exist, and we're going to use those lattice points that aren't accessible in base 10 to build our diagram for 360 degrees. So I hope you can join me for those future videos. Thanks for watching.